Hello, my name is Deborah Ginssberg. I'm the Educational Technology Librarian at the Chicago-Kent College of Law. I talk a lot about blockchain, and recently you've probably read more about this technology too, both what people hope it can do and sort of where it may or may not be going in the future. But there's a lot of talk about it in the legal field, so it's important for us librarians to know about it. Part of the problem with blockchain is, one, there's a little bit of confusion about what it really is, and you can read a lot of text about it, but it's hard to understand, particularly if you're a more visual learner or one who likes to try things out for themselves, and there's not a lot of ways to really try out blockchain. So a couple of things I found that helped are, one, this site, anders.com, has a few tools that are going to be helpful I'm going to demonstrate to you, and then Reuters has a blockchain explain site that also is incredibly useful for getting a good visualization of what blockchain is and how it works. I'm going to start at Anders because I like it because it's so visual and because you can try things for yourself. There is this YouTube video, so if you want to watch the whole YouTube video, he'll walk you through the basics and show you how things work. But if you like to try things out for yourself, there's also a sandbox up here where you can try different parts of the blockchain to see how they work. So one thing we talk a lot about in the blockchain is this thing called tiered hash. And we say, oh, the hash connects one blockchain to the next by being the same number, so each block has the hash of the block before it. But you might be thinking, well, what's a hash? So if I go here to this particular site and click on hash, I can say, all right, let's try putting in some data. Quick, brown, fox, etc. And you can see as I start to type, the hash down here changes. So what's going on is any data I put in here at all, any data from a few sentences to, I could put in the Constitution, I could put in entire books or entire series of books into a single space here. Whatever that data is, it gets a unique address down here. Doesn't matter how much data, it's going to get a unique address. And that address changes as I type. So as I typed, you notice the address changed. And this address refers uniquely to these characters right here. Now, the way the hash is created, I can't take this information and then come up with this data. Instead, it's this is the address of this data. So an address of a house doesn't necessarily tell you what's in it, but it tells you where the house is located. The hash doesn't necessarily say what's in it, but helps you sort of define a kind of location, or at least a kind of identifier. Now, hashes for blockchains have a particular quality to it. They can't just be anything. They have to have some kind of pattern. And usually this pattern and how they start. So for the Bitcoin blockchain, each hash starts with a series of 8 zeros. And it takes some sophisticated calculation. You notice as I typed in the information, the calculation happened really quickly because it didn't matter the pattern of this hash. But it takes a more sophisticated calculation to come up with hashes that meet a particular pattern. So that's when we want to create a block, and the block has to have a pattern. And in this case, this blockchain, the pattern starts with 4 zeros. So it's not as complicated as the blockchain. So as I type, my data in my data box gets an identifier, it gets a hash, but what's going on is it doesn't meet the pattern. So what has to happen is the computer has to come up with an identifier that works for whatever data is here, but it has to meet the pattern. And that is what mining does. Mining looks for the right kind of number, the right kind of hash that matches the pattern. So if I click mine, usually within a few seconds, it will come up with something that starts with 4 zeros. If I add or change this at all, oh look, now the hash doesn't match the pattern anymore because the hash refers to the specific data in the box. I changed the data and the hash has changed too. but I can mine, and in a few seconds it comes up with another number, a unique number, refers to just this data. Again, the date just says I've identified the data, not necessarily what it is, but it meets the 40 pattern. So hash, special address, block with a hash, special address with a special pattern. And in the blockchain, that pattern gets carried from one block to the next. So notice this hash is included in the data for the next block, and this hash is included for the data for the next block. So here is data set 1, and here is data set 2, and here is data set 3. Now notice all of these just turned red. That's because these hashes, while they match, they don't meet the pattern. To meet the pattern, I have to mine. So I mine the first block. Oh, now we've got a matching hash. It's a good block. First hash is nothing, and then the next hash starts with 4 zeros, then a 7. Great. Now this block I need to mine. I need to create its special address. So I mine. In a few seconds, it's created, and I can do that with the third block as well. So now these 3 blocks are connected together in a blockchain. Once this last mine happens, notice this is actually taking a few more seconds. It's become a little, even after a few iterations, it becomes a little harder to calculate. But once it does, which it's done now, this hash number is included in this data set. When we mined, we created this hash address. This hash address is included in this whole data set. And when we mined, we created another unique address. So the blockchain is chained together through these hash identifiers, each of which is included in the next block up the chain. So if you want to play with it, see how data sets change, see how mining works, this is a really good site to explore that on. The video explains more advanced concepts like what are these nonces up here and what do they do? And they affect how the calculations are done. They show you what a distributed blockchain would look like. So here are 3 identical blockchains. If I change something in one of the blockchains, it's no longer identical. So now it's noted as something that doesn't belong in the distributed network, because when we have blockchains, we have one chain that we then distribute on different networks, and one that doesn't match gets dropped. We could talk about tokens, ways to pass value from one blockchain, part of the blockchain to the next, or even a Coinbase, ways to distribute value through a blockchain. So here you can have a chance to try some of these concepts on your own and see how they work. I do recommend, if you've got 20 minutes, to watch this video first. Another place I have seen that explains some of these concepts very well, though not as the same kind of interactivity, is this blockchain explained. Let me go to the top of the page to get started. So Reuters Graphics has created this great blockchain explained site. So it says, okay, what is this database anyway? Well, the database is a record, and any information can be in that record at all. A transaction, text, media, whatever it is you can store. Sometimes the amount is limited, sometimes it's not. Depends on who's created the blockchain. The Bitcoin blockchain does limit the amount that can be stored in a record and in a block. Other blockchains don't have those same limitations. So again, you have some variety from one kind of a blockchain to another, but all of them have a record. All of them then will bundle a bunch of records into a block, and then all of them will chain these blocks together using these using the hashes. So if you're not terribly clear on what a record is, we can play this. Here, there's a trade, and the trade goes into the record. So that's one thing that's gone into the record is a trade between 2 people, and that is now something that the record can go onto the network. And there's lots of records on the network, lots of trades going on the network where people are looking to fit them into different blocks. So someone says, oh, I've got this, I'm going to create a block. It's going to have a hash. I've put that little record in right there. So a block of records is being ready to be added to the chain. And here we've added the block to the chain. And notice that when we do so, the hashes are the same. So one hash ties it to another, just like we saw when we were looking at the blockchain demo over here. And that is what makes the records difficult to change. That's what makes block work so effectively, is those hash codes. They are immutable. They are an integral part of the blockchain database. It's very difficult to change, and that's what helps keep the records safe. So this particular site, it's not as hands-on as the other site, but it does provide a really good visual of how one step leads to another in a more graphic way than the blockchain demo. So if you're having a little bit of difficulty putting this all into your head as to what a blockchain is and how it works, I'd recommend spending some time on these two sites just to get a better idea of how everything functions.